Welcome, everyone. My name is Almiray, and in the next 30 minutes, we will go through a set of Maven features that are bound to make a splash on your daily work. But first, a little bit of history. So you might remember that Java came out roughly 25 years ago, and when it did so with a syntax that's very close to the most popular language at the time, which was C or C++. Now, we didn't have a build system right at the time that Java came out. We only had pretty much make, which was coming from C and C++. But the thing about Java is that it gave us the possibility to write code in one platform and then run in another one. So we needed a build tool that would allow us to also have multi-platform capabilities. Well, a group of developers came together and decided to create the first portable build tool for Java, and that was known as Apache Ant. Whether you like or dislike XML, that's not exactly the point. The thing is that Apache Ant did allow us to build more complex projects, more complex systems, up to a point where another group of developers saw that there was a need for a well-defined structure and conventions and so on. And that's how the Apache Maven project came to be. Besides convention over configuration and dependency resolution and a fixed structure, a few other features were added, and that in turn also allow us to have even bigger, more complex projects. But there was another group of developers that saw that the strict nature of the Maven tool, or at the very least the way that I saw it, was too much. So they wanted to have a more flexible approach, and that's how the Gradle build tool came to be. This is the time in 2007, 2008 or so, and this is when I jumped ship from Maven to Gradle, and I spent the next 10 years looking at how Gradle can be used to create even more complex builds and other approaches. And after some time, I decided to come back to Maven because it turns out there are features that you can find in Gradle, but that are also available in Maven that allow you to have much better projects, much better experience with build tools. So the first thing I'm going to showcase is project properties. Now, project properties may be defined in a couple of ways. You probably have seen them inside a properties block defined inside your BOM file, or may also be typically fields exposed by plugins. These fields are annotated with a notation known as add parameter, which will automatically expose them as properties. Regardless of how they are defined, you may redefine or provide a value for each one of these properties using the command line, passing a key value syntax. Now I'm going to show you a quick example of this. Let's turn into the terminal, and I have a simple project here that contains just one POM. I will already things already compiled. Now the thing is, let's do a clean here, and let's compile. Before I do that, let me show you which version of Maven I'm currently using. I believe the latest version at the time of publication, which is Maven 3.6.3, and I'm using some version of Java 8. All right. So if I compile the project, I will expect the classes to be Java 8. Now we can check this quickly by decompiling the code and looking at the first 10 lines we had. And turns out that the major version is 49. Now 49 is definitely not Java 8, that's actually Java 5. Now how can we change this? Well, there are a couple of ways. We could open the POM file, which I should have shown earlier, which is a very trivial POM file just like this one. And we could define the Maven compiler plugin plus additional properties, or could define the values for the specified properties, Maven compiler target, Maven compiler source, in the properties block, or we can even pass them on the command line, which is exactly what I'm going to do right now. Let's do a clean to make sure that nothing is there, and then compile to pass that property, Maven compiler target. There is a typo here, and oops, and then we change this to 1.8. Then compile the code, and when we look again into the decompile class, now we have major version 52, which turns out to be Java 8. Now, any property that is defined in your POM file can be overridden in such fashion. This will come in handy in a few moments. So let's go back to the slides. And the next item is that you can pretty much invoke any Maven plugin on the command line just by passing the gap coordinates, which stand for group ID, artifact ID, version, plus the goal, and any other parameter that may be needed. For example, if I wanted to apply the eco plugin, which is not available by default in any Maven plugin, any Maven build, then I'll have to use invoke a command line like similar one that is shown in the slide. So Maven plus the group ID, artifact ID, and version of the plugin, which is 120. Then the goal, which is echo, and then pass any additional parameters. Now, the echo message is one such of those fields exposed by the Maven plugin. And because we know that we can override the values using the key value combination, then this should work. Now we come back to the terminal, and I can show you an example of this working. I think I have a predefined command I can show here, which is exactly, well, this is not with echo, this is exactly with exec. Because as it turns out, the class that we have in this project is executable. And I can show you quickly like this. It's a simple hello world. Right, so going back to the command line, and if I want to execute this class, I can define that I want to use the exec Maven plugin with its gap coordinates, the Java goal, plus any additional parameters, in this case, the exec main class, which is needed by the plugin. So if I just exec this, pass it through the shell, I should get something like hello world, which is right there. Now, there is another thing, is there is a subset of well-known Maven plugins that can be executed just by passing the plugin ID. Exec happens to be one of those. And then you can shorten the command line like this, just the ID of the plugin, to know which plugins are automatically available are those that are part of the org Apache Maven group ID or org codehouse module. Any other plugin will have to be executed with the long gap coordinates. So if I execute command number 2 and pass it through the shell, it should give us the same result as the first command, which is right there, hello world. Now finally, I have the command for execution the echo plugin. So that's Maven plus the gap coordinates, the goal, and a message. And we can execute it like this. Again, pass it. And the first time we see that Maven downloaded the Echo Maven plugin because it was not available on my local repository. After the execution, which we see here, hello world from Echo plugin, everything works fine. If I were to execute this again, notice that there is no longer a need for downloading the plugin because it's already available in my Maven local repository, and it simply goes ahead and executes the goal. So this is working as expected. All right. Now we turn into dependency resolution, which is one of the greatest features that Maven added as opposed to what Ant provided at the time, but it's also a constant source of headaches. And the reason being is that it's usually understood that dependency resolution is simple in nature, but it has very interesting rules, and the way that we handle dependencies is different depending on whether you are using or declaring a direct dependency or a transitive dependency. So basically, you define dependencies in a dependencies block. These are known as direct dependencies. Your direct dependencies may have additional dependencies. These are known as transitive dependencies. And the rules of resolution are like this one. The dependency, the direct one that is closest to your current POM, is the one that is going to win. But it's also the last one that is found. So you may have a dependency, for example, in Guava on your first POM, and then your parent POM may have another dependency on Guava, or you go up in the hierarchy. Well, the one that is going to win is the version that is defined on your POM, not on the hierarchy. And transitive dependencies are resolved in a different manner. you will find that actually Maven calculates how many hits or how many hops it has to go through in the dependency graph in order to find a dependency. And the one that has the shortest path is going to win, regardless if it's defined first or if it's defined later. So I did a quiz a few months ago. I think it was in March of 2010 this year. And I presented a couple of questions actually, where were like 14 questions on how to deal with dependency resolutions. Now I'm going to showcase only two questions here. The first one is this. You have two dependencies, same group ID, same artifact ID, but different version. Now the question is, if I were to resolve these dependencies, which version is the one that's going to be chosen? Is it going to be version BOM 27 because the first? Is it going to be version 28 because it's the last, or it's because it's bigger in terms of semantic versioning? Or because these are duplicate definitions, this should turn out into a build error? Well, it so happens that Maven does let you run the program. It does not cause an error. It actually tells you there's a warning. You can tell it right here. It says, for this particular group ID and artifact ID, there are two versions. There might be a collision. There's version 27 and 28. And by the way, the version that I'm going to choose is going to be 28 because that is the last one, because these are direct dependencies. All right. So the next question that I ask is, well, what happens if we have Guava as a transitive dependency? Now, this is completely unrelated to Guava. This is just direct and transitive dependencies. So Google Juice has Guava as a transitive dependency in one hop, and Truth has also Guava as a transitive dependency in also one hop, but these two versions are different. Juice says it's version 25, Truth says it's version 27. So we know by now that this shouldn't cause a build error. Now, which version is going to be chosen? 25 or 27? As it turns out, it will be the first one that is found in terms of transitive. In this case, it's going to be the version from Juice. Now, I can actually showcase that the order and how we define these dependencies matter. So let's change into this project. And we can quickly see the POM file, which is the one I'm going to show in the slides. And if I were to invoke Maven dependency tree, this will tell me the resolved list of dependencies. And here we go. Version 25 is the one that is chosen. By the way, the invocation of the dependency tree is using the shorthand notation for plugins. The dependency plugin is not available by default, but it's in the well-known set of plugins that can be invoked just by calling plugin ID. And then tree is just the goal. It's a bonus. Let's go into transitive 2. And here we can see in this POM file that I switched the order. Truth is first, Juice is second. If I were to resolve dependencies now, you will see that the version of Guava that is chosen is version 27. All right. Is there a way that we can fix this? Is there a way that we can tell Maven to use a very specific version of Guava? Sure, we can. We could define a direct dependency, which will win over the transitive ones. Or even better, what we can do is use the dependency management block, like so, to define which version of Guava I want. So in the dependency management block, basically this works like a lookup table for any dependency. As long as there is a match for the group ID or artifact ID, then the chosen version will be the one that you have defined in that particular block. So in this case, even though Truth and Juice will depend on a different version of Guava, the chosen version will be the one that I have specified right there, which is version 29. Don't believe me? Let's invoke Maven dependency tree here. And you'll see quickly that the resolved dependency graph will show that the chosen version is Guava 29 as expected. All right. So Robert Schulte is the Apache Maven PMC chair, and he has something to say about how Maven resolves dependencies. It turns out that Maven never looks at the version number. It only looks at the location in the graph. So that's why direct dependencies and transitive dependencies resolve as they do. And he also says, well, this idea of how dependencies should be resolved was done many years ago, and it may be the time to reconsider this in the future, given how projects work now. Perhaps semantic versioning will be a thing that we will see in a later version of Maven, but for now, if you need to fix this problem, then use the dependency management block as just shown. An alternative will also be to apply the Maven Enforcer plugin in your build. The Enforcer plugin contains or provides a series of rules that allow you to define how you want your builds to behave. If there are duplicate dependencies, then there should be a breakage, not just a warning. There is another rule for ensuring that it's called dependency upper bounds, which will give you semantic versioning capabilities. There's another one for dependency conversion in case that there are two different versions of the same property, then the build should fail, just like happened with what we had in use and truth. I really love the fact that Maven is the Enforcer plugin is known as the loving iron fist of Maven, because if you configure it, you will quickly fail your build. It may be the case that your builds right now are working, but that is just by sheer coincidence. It's likely that you have few issues in your builds. It may be different bytecode versions. It may be that you're missing dependency conversion, and the Maven Enforcer plugin will tell you this immediately right away. Now, I did a non-unscientific poll on the usages of the Maven Enforcer plugin, and of course, it's just a tiny sample, but there are not that many people out there that either know what the Maven Enforcer plugin is, or that even though they know it, they do not apply it. So it would be a good idea to just check it out, and you'll see quickly how your builds are behaving, and perhaps you can define ways to make it better. I'm going to go quickly to the results of the quest. Turns out that only 507 people out of 509 solved all questions correctly. And one thing that was surprising is that 1/3 of respondents thought that the first question that we saw when you have duplicate dependencies should cause a build error, and only 1/3 or close to 1/3 found the right version. And for the question number 5, also that it was resolving the transitive dependency one hop, was a little bit undecided which way they should go. Now the link for the quiz is right there. There are a few other analyses and results and outputs that are interesting to read. So I will certainly encourage you to have a look at this one. If you have ever encountered problems with resolving dependencies, and it's not just versions, it's also bytecode, it's also shadowed classes and duplicate classes, I highly encourage you to have a look at this presentation by Ray Senk and Robert as well, where they go through a series of scenarios that actually the Google team encountered, and they come up with different solutions for these problems. That particular link contains a reference to the slides and the documentation and the source code. Next, we're going to go with Maven cleanstall, which is pretty much a cargo code. So the first rule of Maven Club is you do not invoke Maven cleanstall. Now, as you will expect, the second rule is you definitely do not invoke Maven cleanstall. The third rule is instead prefer to use Maven verify. Or if you prefer a more lighthearted way to say this, Maven verify will put rainbows on your builds. What's going on here? As it turns out, you may know that in a multi-project build, the project runs in something that is known as Maven session, which is pretty much something that from the very old days of Maven 2 is known as a reactor. Maven 2 used to have multi-project support as a third-party plugin, known as the reactor plugin. In Maven 3, that behavior was added into core. From the days of Maven 2, you really had to invoke clean most of the times because, again, reactor was just an afterthought. But since the reactor was added into core, we have access to what is known as incremental builds. If you rely on incremental builds, if the plugins that you're consuming are also aware of incremental builds, that means your builds can be faster because you don't need to recompute intermediate results, such as compiled classes or process resources. But the moment that you invoke clean, then all those intermediate results are completely deleted and you have to restart again. Another thing that happens when install, the install goal will go through pretty much all the life cycle phases that you're interested in and finally publish the artifacts to your Maven local repository. But if the only thing that you need to do is just test out the project, Maven verify everything that you need, install, as a matter of fact, is the next life cycle after verify. You don't need to publish artifact to local repository because I/O may be expensive. So Robert has another presentation on DevOps 2019 about this particular topic. Why, and he explains with further detail why it would be a good idea to avoid clean uninstall and prefer verify. In most of the cases, there are still valid use cases for invoking clean and invoking install. All right, moving on. Here is a feature that I really love, which is given that you may have a project that has a lot of multi-modules, you would like to invoke just a subset of the module, so kind of like a subset of the reactor or a partial execution. Right now, for every goal that you define in the reactor will be invoked on every single project available in the reactor. But if you pass -PL, that stands for project list, it will only invoke the goals on those projects found in the project list. You may find that some of those projects have interdependencies with siblings, in which case it's a good idea to invoke the -AM flag, which stands for also make. This will result in the small set of projects that you really care about and any other interdependencies that are needed within the reactor. So let me show you a simple example here. Let's go into another set, which is partial number 1. All right. So right now, this build turns out to be 4 subprojects with a root. The root looks like this one. It contains the 4 modules, project 1 up to 4. We see project 1, that is a simple POM like this, just gap coordinates, reference to its parent, no dependencies. And when we look at the one for 2, gap coordinates, and it depends on project 1. And we look at project 3, gap coordinates and depends on project 2. And finally, project 4, I believe, similar to project 1, that has no additional dependencies. So say that I want to build the whole reactor. So we know we simply need to do something like this. Maven compile and invokes the goal in all 5 projects. I could now do the following. I just want to invoke the following goals on project 2 and any other dependency that it requires. So let's do clean compile on it. And we see now that there is a sub-reactor here. It's only 3 projects. That's great. Now let me show you that in project 3, I believe we have an executable class like this. So we know that we could do the following, do maven-am-pl and project 3 and execute Java. And I believe the main class is exec main class come acme main, right? So this should execute the main class for our project 3. Let's do clean compile just because, and let's see what happens. We do have the right amount of projects in their sub-reactor, but notice this, the class come acme main does not exist on which project? The root one. So what is going on here? Well, remember that I said, every goal is invoked in every single project on the reactor. The exec plugin does not make any sense for the build or the other projects. So in order to make sure that you could invoke exec in project 3, what you need to do is add the exec plugin to every project. So you will make use of the plugin management block. You may also need to define dummy values for some of the properties or parameters that the plugin requires. Otherwise, things might not work. And why do I mean by that? Let's look again into a different version of this, which will work. Now, the root project defines two properties which match the parameters expected by the exec plugin, defines the exec plugin in the plugin management block, and applies the exec plugin so every project will have access to it, but is skipped by default. How do we know this? Because of the exec skip property. Right. And when we look at project tree now, this one defines the class that we want to invoke, and also it makes sure that the exec plugin is enabled. So with this in mind, now I can invoke our project like this. We can run it just by simply saying exec Java. Let's see. Here we go. The output is 1 to 3, which is what project tree, the main class from project tree will do. And notice that for the other projects, so let's say here's the build project, the exec plugin is skipped. For project 1, the exec plugin is also skipped. For project 2, it's skipped. And of course, for project 3, it's executed. And project 4 was never reached because it's not part of the sub-reactor, which is what we expect. All right, moving on. Aggregating POMs. This is something that we have already seen. Basically, an aggregating POM is a POM that contains a modules section. Now, you will typically see that aggregating POMs are parent POMs, but they do not have to be. You may have an aggregating POM that is completely unrelated. So you have different modules that are completely unrelated from one another. Notice also that the value module is a path. It's not necessarily a project name. But because the standard convention for Maven is to have one directory layouts or single directory layouts, then the name of the project matches with the path of the project. Here we can see quickly, I believe we have another example, which is the aggregator, right? So this project looks like this. Let's say we have commons lang and you find a bug in commons lang, and you have a project which is the one that consumes common lang. You want to fix a problem in commons lang. What do? Well, you probably copy the repository, try to fix the problem, push to a local repository, and then consume, and then iterate as long as you are not able to fix the problem. But if there are a way to iterate even faster is by using an aggregator. So commons lang or whatever have you as a dependency is just a regular project. I'm using my custom version 99 so that it doesn't match anything that is already published out there. And in my project, I simply depend on that one. And in the aggregator is the one that has the secret sauce, which simply says I'm a POM with the group ID and version and artifact for this aggregator makes no sense. Could be anything you want to. Packaging POM and the two modules. So now I can simply say maven clean compile, and notice that this will compile commons lang, will also compile my project. And because my project depends on the right version of my commons lang, everything works out. So in this way, I can iterate faster. I can call test on commons lang and my consumer project. There are a few more things that I would like to show. Just quickly, BOM files. The way that you define a BOM file, actually, this is not a very good one. The idea is to define all the sub-modules that belong to your multi-project build so that it can be easily consumed. In a way, we define a set of dependencies inside dependency management. This is how we produce a BOM file. And how we consume them is by in the consumer put also inside the dependency management block, the group ID, artifact ID, and version. But notice that we also need two additional properties. We need a scope of type import and type, which has to be POM. If that is not the case, then Maven will not resolve properly the dependencies. And then we can simply consume the dependency without a version. Now, I know this has been very quick, and Maven is quite a simple tool, as it turns out, but it can also be complex underneath. I will recommend you to have a look at these resources if you want to know more about the basic of Maven, about dependency resolution, the structure, and if you happen to be stuck with Gradle and you wish that Gradle has some of these Maven features, then the last link will provide a set of plugins that give you these capabilities. So with this, I thank you very much, and I'd be willing to help you at any time. Just ping me on the internet, Twitter. Just send me a message, and if you have any questions, well, I'll be very happy to take them online. So thank you very much.